Let's head on to another program. We'll go to the Python shell, open a new file. We'll save it in the same folder as IoT_basics, and in that we're going to save it as let's say arithmetic_operators, right? Save them. All right, let's say a is equal to 7, b is equal to 3, and all we have to do is learn a few arithmetic operators. For now, what I'm going to do is I'm just going to print what? I just need to say, first of all, I'm going to print a string which says a plus b is equal to what? Okay, now this is a string. This will print this a plus b exactly as it is. And this will not add a and b. Remember that. This will not add a and b. Okay, so what you can do is, I'm just going to show you how to add by using the arithmetic operators quickly. Let's say a plus b, print a minus b, print a multiplied by b. These are the operators which we can use. A divided by b, save, and then I run. Now when I run, it says, okay, a plus b is 10, 7 plus 3 is 10, 7 minus 3 is 4, 7 3s are 21. Now I don't know, I'm seeing it from here, right? I exactly don't have anything written out here. That what am I doing? I don't know. So what I should say is I should give some good documentation, or I should give a good statement-like form. So I should tell the user the value of my a is what? The value of my a is the variable a. The variable a. Now remember, there is a comma that I'm putting out here between two things that I'm printing. This is a string which I'm printing, and this is the variable a that I'm printing. Each of them are separated by a comma. Okay, you can't use a plus directly. Okay, now you will say, all right, what is there if I use a plus? Okay, what is there if I use a plus? But it will give you an error which says you can't convert int object to a string implicitly. A print can print only one object, only a string. If there is a string, you can't print understands this is an integer. Now an integer cannot be added to a string. That's what he says implicitly. You need to convert it explicitly into a string, and then you need to run it, and then it will say, okay, a is equal to 7. Now that's not a very good way, right? So what I'm going to do is, I'm just going to, for now, I'm just going to print the variable a, and I'm going to print the variable b. I need to tell the user that b is equal to what, and then I need to tell the user I'm going to do the following things, that is a plus b, this is a string, is equal to your a plus b, a minus b is equal to your a minus b, right? Your a multiplied by b, a multiplied by b is equal to, again, a multiplied by b, and your a divided by b. Is your a divided by b, right? I need to say that to the user in a very good format. So now if I save it and if I run it, it will say a is equal to 7, b is equal to 3, a plus b is equal to 10, a minus b is equal to 4, a multiplied by b is 21, a divided by b. Now the division is a real division. You exactly get the answer just like the mathematical division 7 divided by 3. Generally in programming languages, this is not a real division, this operator. This gives you a division which just gives you the decimal part. It does not give you the, it just gives you the integer part. It does not give you the decimal part. So if you want the other kind of programming language division, that particular division is called as a floor division by b. That is divided. If you go into the, it's something like this. A divided by B. So if I save it and run it, it will say A divided by B. The floor division, only the integer part of it, is 2. Okay, so that means it is like getting the quotient when you divide A divided by B. So there is a quotient and there will be a remainder. If you want the remainder after dividing by B, so if you want the remainder, A mod B, if you want the remainder, you need to say something like this, A mod B, and then you need to say A modulus B. Correct? Save, run. So you have A modulus B is equal to 1. Alright, one more operator and that's the end for arithmetic operators. Let's say A raised to B. A raised to B. So that's going to be A raised to B, which means it's going to be 7 cubed. 7 raised to 3. That is 7 cubed. Are you able to understand? A raised to B is your 343. So you can change values of A and B. You can make them, 84 and BS, or instead of 84, let's get it to 8, and you can make this 2. Save, run. You can have something like this, right? A modulus remainder is 0 after division. Correct? Let's say something like, if I change the value to something like 2 and 8 this time, and if I run this, it will give me, okay, so 2 minus 8 will be minus 6, and it will get a floor division will be 0, but remainder will be 2. So you have a couple of things that you can do. Now, I want you to experiment with, though this is not a part of, this is not so much part of this, but I can also experiment by saying minus 7 divided or modulus with 3. So if I say enter, and if I go into that, okay, can you see what happens? Especially over here. What is the division? It is minus 2.33. Now you would have expected a floor division of minus 2, but you got a floor division of minus 3, not a floor division of minus 2. So why is that so? Okay, so that is a question which, of course, it doesn't have much to do with the with much of IoT as such. So I leave that as a question for you to think upon, and I won't give you a solution. You can either ping on the website, put up a query or something like that, or you can even check it out in Google, why so. But I want you to research on the same. Okay. Also, why is A modulus 2 is equal to 2? Why is the remainder 2 when you have a negative number? That also you need to check. Because when I put it as 7 and 3, if I just put a 7 and 3, my A modulus 2 is actually 1. How come it became 2 when it became minus 7 modulus 3? I want you to just think about the same. So this is about arithmetic operators. Okay.